Okay, so this is lesson 3.3, formulas for common compounds, and you will have to use the periodic table for this section to get formulas. All right, so scientists from all over the world, they need to be able to communicate. So even though they're speaking different languages, they need to have a common language in chemistry so that scientists all over the world are talking about the same chemicals and they're talking about the same chemical reactions. So there is a common language that scientists use to deal with chemicals and chemical reactions, because all over the world, different chemicals, people have common names for different chemicals. So that's why there had to be this common language between all the scientists, so that when they're discussing a chemical, they're discussing the same chemical. So the common language that scientists have devised, it is the chemical symbols and names for the elements and compounds. So for example, water, we know water, that would be the common name for water, but the chemical formula for water is H2O, and it actually has a chemical name as well, which is dihydrogen monoxide, and that would be its chemical name. The chemical formula for water would be H2O. All right, so here again, we're just looking at water again. The symbol for hydrogen is H. So this H here, you would use your periodic table to find out what the H represents. In this case, you probably already know the H is the symbol for hydrogen, and the O here is the symbol for oxygen. There's also a little bracket here with a little lowercase l, and that actually represents liquid, and we'll go through that a little bit later in the next couple slides. So what we see here with H, we see the H2. There's a subscript of 2 there beside the H, so it's on the bottom right. There's that little subscript of 2. That means that there are 2 hydrogen atoms in this compound. All right, so that's what that little subscript of 2 means. Then when you look at the O, there is no subscript beside it, but we know that there is an O present, so it means that there is 1 oxygen present. All right, don't confuse this little bracket as a 1. That is actually a letter, the letter L, representing liquid. All right, so there's 1 oxygen atom in this compound. So anytime you see an element with no subscript, it means that there's 1 atom of that element. And then, yes, then here that little subscript L shows that it's a liquid at room temperature and under normal atmospheric pressure. And then here in this diagram, we also can see that there is 1 atom of oxygen and 2 atoms of hydrogen to make water, which is H2O. Okay, so here we're looking at chemical names and formulas. So this example above, we have sulfur plus zinc makes zinc sulfide. So in this example, we're using the chemical name for the reactants and the products. But using the periodic table, you can also get the chemical names of all the elements and their chemical symbols. So when you look on the periodic table, each element has a symbol. It consists of 1 capital letter, or it might have 1 capital letter and 1 lowercase letter. So for example, sulfur here, when we look on the periodic table, sulfur, the symbol for sulfur is just capital S. When you look at the symbol for zinc, in the periodic table, it's a capital letter and a lowercase letter, and the formula is Z, capital Z, lowercase n. So that's the chemical formula for zinc. And then information about the chemical composition and structure of a compound is given by its chemical formula, again, which is its symbol. So zinc sulfide, which is our product, has the chemical formula ZnS. So that's the chemical formula for zinc sulfide. All right, so anytime when we are naming, in this case it was zinc sulfide, we name the metal first. The metal is zinc, and then we follow it by the name of the non-metal, which was a sulfur. And we change the name of sulfur, so the name of the non-metal gets changed to "ide." The suffix becomes, instead of sulfur, it becomes sulfide. Okay, and then we basically replace the names of the reactants with their chemical symbols, and then we replace the name of the product with its chemical formula. So in this case, it becomes S8 for sulfur, and then we have Zn here for zinc, ZnS for zinc sulfide. And we'll talk about these coefficients, like the coefficient of 8 and 8 here. We'll talk about that later when we get into balancing. The last thing here are the subscripts to indicate the state of the metal. So here we can see there's an S, S, and S as subscripts in brackets. So the S represents solid. The L we talked about represented liquid. If there's a G, lowercase g, it represents gas. And lastly, if you see an AQ in brackets, that represents aqueous. Aqueous means it's a substance dissolved in water. Okay, so not everyone is a scientist, so many chemical compounds are often identified by a common name, such as water, such as table salt. We've talked about those a little bit already. So these names are easier to use, and they've existed since before the international naming system was created. So again, sodium chloride, NaCl, it's a solid, and then water, H2O, it's a liquid. And the chemical name of water is dihydrogen monoxide. All right, in this chart, we just see some chemical names and formulas of some common chemicals, and this is in the textbook as well. It's table 3.1. So for example, sugar, table sugar, or the white sugar that we use in baking and coffee and tea and so on. So table sugar is called sucrose, and here is its chemical formula. So C12, C represents carbon, so 12, subscript of 12 means there's 12 atoms of carbon. Then H22, that means there's 22 atoms of hydrogen, and then O11, that represents 11 atoms of oxygen. Another common one is like this one here, baking soda. Common again, we have it in our fridges and we use it in baking. Its chemical name is sodium bicarbonate. And if we look at the chemical formulas here, we have Na. Na is sodium. And then we have H, which is hydrogen. Then we have C, which is carbon. And then we have O3, which means there are 3 atoms of oxygen. And lastly, that little s represents it's a solid. All right, so we're going to stop here, and there are questions to do for 3.3. They're on page 51 in the textbook. Again, it's number 1, but it is broken down into A to E.